In 2019, I gave a talk called The Journey to 1 Million. That talk was about how I introduced fiber-based concurrency to Ruby, making fibers both practical and efficient. Today, I'm here to talk about Falcon, a web server that uses one fiber per request. Because fibers are lightweight and cheap to create, they provide more opportunities for concurrency. So we deployed Falcon to production at Shopify, replacing some of the existing Unicorn and Puma deployments. It's now handling about 7 billion requests per day. So it's like a big number. And as a result, we retired thousands of servers by consolidating workloads onto Falcon. And the simplification saved us millions in operational costs by eliminating the need for Puma. At RubyBuild Conference 2019, I talked about climate change. The tech sector produces around 2 to 4% of global emissions, and I believe inefficient software is part of that problem. So building efficient, scalable systems means using fewer resources to achieve the same outcomes, and that's better for the planet. So I wondered what I could do to help. My skill is Ruby, and Ruby is everywhere. So making it more efficient felt like a meaningful way to make a difference. Every time a company adopts Falcon, I feel one step closer to my goal. We handle more load using less servers, and we can keep using the language we all love, Ruby. But this is just the start. For a long time, this was a personal journey, and now it's time to focus on growing Falcon's adoption. So we've proven that it works at Shopify scale. So I want you to replicate that success with confidence. So here's how we'll approach it. First, we'll look at building with Falcon, specifically how to use it with Rails to create high-performance web applications. Next, we'll cover deploying those applications to production, making sure you know how to use the tooling correctly. Finally, we'll talk about monitoring applications on Falcon so you can keep them running smoothly and reliably. Building great web application with Falcon has never been easier. But before we talk about that, let me bring everyone up to speed on what Falcon is and the technology that underpins it. So if you didn't know, Falcon is a web server built on top of Async, a framework for concurrency in Ruby. And Async is built on top of the IO event gem that provides the event loop implementation. It coordinates with Ruby using the fiber scheduler interface to manage the execution of fibers. The fiber schedule interface exposes a set of hooks, and together, these form the essential plumbing of Async. The Async gem provides high-level building blocks for concurrent programs, and this foundation powers Falcon. Falcon itself uses Protocol Rack to run web applications in a fiber per request mode, unlocking the scalability of the event loop design. And on top of Rack, we use Rails to build your application alongside a variety of related technologies. So today we are going to be talking about how to use Falcon with Rails, but many of the things we talk about will apply to any Rack-compatible framework. So let's start by creating a new project. We are going to remove Puma and replace it with Falcon. Now when we launch the Rails web server, you'll notice that it says Building Falcon. And if we open the application in the browser, we see this familiar welcome page. But this is HTTP 1.1, a protocol that was established almost 30 years ago in 1997. Surely we can do better. So let me introduce the Falcon serve command. It defaults to HTTP2 with TLS, and that's because HTTP2 in the browser requires TLS encryption. And it's a good idea to develop and test in the same environment that we're deploying to. However, if you open the browser, you'll get a warning because the TLS certificate is not recognized. We are going to solve this problem using the localhost gem, which provides self-signed certificates for local development. So let's run the bake localhost install command. We'll be asked to authenticate with the system, then a development certificate will be installed. Now instead of this, we will get this, and we can confirm it's running on HTTP2. The localhost gem also works fine with Linux. So Falcon is the only rack-compatible server that delivers both HTTP2 and TLS by default, which makes it a great option for developing modern web applications. Okay, so we have the basics working, but one question that often comes up is, does it work with Active Record? Actually, Falcon is extremely good at non-blocking I/O, including database queries, but Rails still defaults to one database connection per thread, which is unsafe when running with Falcon, since Falcon can handle multiple requests on the same thread. So we need to add this configuration to our config application file in Rails. The first setting prevents Active Record from being used in a way that can leak connections, which is actually a good idea for any Rails application. And the second setting instructs Rails to use request per fiber isolation, ensuring that each request gets its own unique database connection. With these changes, everything just works on Rails 8. So here's a small example. Basically, it's a pizza oven, where we create a new pizza, inserting it into the database, then we cook it, which updates the record in the database to cooking. We sleep for a short duration, and then we update the record again. When we run this example with Falcon and Perma, at low levels of concurrency, we don't see much difference. But once we start increasing the number of connections, we can see a significant improvement in Falcon's performance. Now, you might argue, let's just increase the number of threads. Surely it's not fair that Perma has only 3 threads per worker, and Falcon can create an unlimited number of fibers. So okay, let's try that. So even if we give Perma more than enough threads, Falcon is still more efficient, and the gap continues to widen as we throw more connections at it. Of course, this is a very specific benchmark, but we got over 200% throughput with the same hardware resources. So Falcon has great support for Active Record. Now let's talk about Active Job. Active Job works fine with Falcon, but existing job runners like SolidQ and Sidekick are not async aware. As with Perma, we expect similar concurrency limitations, especially when I/O is involved. So I built Async Job to unlock greater concurrency for background jobs. Let me show you how it works and how you can use it. Async Job is just a generic queue interface, which means that it doesn't actually know about how to serialize or execute jobs. In brief, we enqueue job data into the queue and then later dequeue it. The queue itself could be in memory, using a database, using Redis. It's an internal detail. So we need to wrap the queue with the interfaces expected by Active Job. In essence, we need to serialize the Active Job, pass that into the queue, and then later on deserialize and execute it. So this functionality is provided by a separate gem that connects Active Job with Async Job's queue interface. It's actually a nice design because we can directly execute jobs without any additional overhead. Most other adapters have wrappers that make job handling more complex. Let me show you the Sidekick queue adapter for Active Job. See here, we actually have a job wrapper, and the sole purpose of that wrapper is actually just to execute the Active Job itself. So what we have is a Sidekick job that contains an Active Job. In contrast, the Async Job queue adapter directly invokes Active Job. There is no wrapper. Here's the Async Job queue executor for Active Job. We directly deserialize the job data, and then we execute it. So it's a cleaner design with less overhead. So to use this, you need to add the Async Job adapter Active Job gem to your project. Then we need to define the queues for job processing in your Rails application. We're going to define 2 queues, a default queue and a local queue. The default queue is going to use an aggregation to batch jobs into Redis. This avoids latency during job submission. We're also going to include a local queue which processes jobs in the background within the same process. This kind of queue can be exceptionally fast but is less reliable. Then if we want to use Async Job exclusively, we can set the global queue adapter in config application. Alternatively, in our job definition, we can set the queue adapter here, and we can also specify which queue to use per job. So I compared Async Job with Sidekick, and they were pretty similar, but Async Job performed exceptionally well. Note that the Redis processor for async job has many of the same reliability features of Sidekick Pro, although it's definitely not as mature. I also had feedback from a user who compared solid queue with async job and found that it was a significant improvement, but I didn't perform this benchmark myself. So for fun, I created a small demo that combines active job, active record, and action cable. So here's an active record model that broadcasts to an action cable stream when it is created. And here's a background job that creates the model object. And here's a controller that creates the background job. Here's the view for that controller. And here's the form that lets us submit a request to create a job. And here's the table, which is updated when records are created by listening to the job executions stream. So let's open the demo in a browser. And in the console, we can see that the browser successfully connected to action cable using a WebSocket. Then if we submit the job, we can see in the logs that the job was enqueued, and then the new record was sent over the WebSocket to the browser. Then the table is updated. So we can see that Falcon works very well with active job, and you can choose to use the async job queue adapter if you want better performance. That demo was using action cable, which only supports HTTP 1. But Falcon defaults to HTTP 2. So how is this working? Well, it turns out that most browsers, Safari, don't support HTTP 2 WebSockets. Instead, they make a separate HTTP 1 connection. Except for Chrome, which tries repeatedly to connect using HTTP 2, failing every time. To fix this, I created the async cable, a gem that replaces action cable's implementation with async WebSocket, which supports both HTTP 1 and HTTP 2. Now if we go back to our example, notice that the WebSocket connection is working correctly. We can see that the status code is 200 OK, which indicates an HTTP 2 WebSocket connection. If this was HTTP 1, we would see 101 switching protocols. In addition, async cable performs better than action cable. I did a quick benchmark, and async cable had more than 2x the messaging rate. So action cable is supported, but with async cable you get better compatibility with HTTP 2 and improved performance. Now, action cable is okay for some use cases, but if you need ordered message delivery or simply need more control over the message stream, you might want to use a streaming response. One of Rank 3's major features was real-time bidirectional streaming, and we can take advantage of that to deliver in-order messages. For example, this classic song, 100 Bottles of Beer on the Wall. Here we create a body proc, which takes a stream argument, and we write to the stream one line at a time. Then we respond with that body proc, which the server then uses to stream the output to the browser. You can use this technique to implement basic streaming, server-sent events, or even WebSockets from within your Rails application. Of course, that example is a bit boring, so how about this one? I'm sure some of you have seen this demo before. It's actually a Rails application running Flappy Bird in the browser using server-side rendering. The user input is streamed to the server, and the HTML is streamed back to the browser using an async WebSocket. It even supports multiplayer. So Falcon offers excellent support for real-time interactive streaming, giving you more control and flexibility and enabling new experiences for your users. Okay, so in summary, Falcon defaults to HTTP 2 and TLS with self-signed certificates. Active Record is fully supported in Fiber mode. Active Job works, and you can take advantage of async job for improved performance. Action cable mostly works, but async cable resolves compatibility issues with HTTP 2 and improves performance. And finally, Falcon has great support for real-time bidirectional streaming using Rank 3's official specification. Now, you've built this wonderful application with Falcon, but how do you deploy it? During development, we used Falcon Serve, but it's not designed for deployment. Basically, because it's hard to configure all the options you might need in a production environment. So now let's introduce Falcon Host. This command reads a falcon.rb service configuration file that defines your application. Let's take a look at a typical configuration file for a Rails application. Firstly, this is actually an executable script using the Falcon host as the script interpreter. Then we define a service using the host name of the application we want to run. The service includes the rack and Let's Encrypt TLS environments. Those provide all the default configuration that we want for a standard Rails application. Now we can run the application, and it logs that it's binding to a Unix domain socket named application.ipc. This is the default because the expectation is you configure this as part of a reverse proxy setup. Alternatively, if you want to bind to a specific port using unencrypted HTTP, you can write the configuration like this. Here we specify a custom port and endpoint. Now we run the server, it binds to the endpoint we specified, listening on port 3000. Actually, this service configuration file is implemented using the async service gem, and it's possible to include other services. For example, we can also include the background job service as part of our web application. This service includes the async job adapter active job environment, which will run our background job queue. And so we run our web application and look at the process tree. We will see both the Falcon server processes as well as our background job processes. So Falcon RB defines your deployment, including all your services, making it easy to deploy anywhere. So that's the basic strategy for hosting a Falcon application. But what about virtual hosting? Let's talk about Falcon Virtual. In the past, at least, it was very common to host multiple applications on the same server. And Falcon Virtual lets you run multiple Falcon RB service files and binds to both secure HTTP as well as insecure, secure HTTPS as well as insecure HTTP. The insecure endpoint, plain HTTP, redirects to the secure HTTP endpoint by default. And the HTTPS endpoint supports hostname negotiation to select the correct application. And so that's it. It's really simple to implement virtual hosting with Falcon and host multiple applications in the same server. Now let's talk about systemd integration. The async container that runs each service supports multiple process readiness protocols. That's the mechanism that says, hey, I'm ready to go, or oh no, I've failed for some reason, to the parent process. And so we have built-in support for type equals notify, which is basically the best process readiness protocol to use in systemd. Then all we have to do is run Falcon Virtual, and we can pass in the wildcard for all the web applications we want to run. And so that's it. Falcon has great support for systemd integration directly into the service framework it provides. And so it makes it exceptionally easy to use with minimal configuration. Alternatively, if you're using Kubernetes, we also have support for that. Because of the way Kubernetes is designed, we need to use a log file to communicate with the readiness probe. So we need to specify the notify log environment variable, and then we can use this command to poll the log file. For the liveness probe, we need to use an application-specific check, and Rails already includes an HTTP endpoint for the health check. Here's an example of what that looks like. So we can just use this directly. To be honest, I wish Kubernetes followed the same model as systemd. It feels a bit ugly to have to use a separate log file, but it works well enough. Okay, so in summary, we've shown how to use Falcon host with a Falcon RB service file. We've shown how you can add multiple services for simplified deployment. Then if you have multiple web applications, you can use virtual hosting. To actually run this, we have good support for both systemd using notify socket and Kubernetes using notify log. Okay, so you've built your application and you've deployed it, but how do you know it's performing well? Underpinning Falcon and async service is async container, which manages all the child processes. That also includes health checks, which are an important and automatic part of keeping your application online. Specifically, if a child process hangs or the event loop stalls, it will be detected, and if that happens, the child process will be forcefully restarted. Here's an example log showing a failed health check and the subsequent process termination. So by default, critical issues in your application will be detected by the health check. In addition to that, there is a special service that we can run adjacent to your web application called the supervisor. The supervisor can perform various functions like monitoring memory usage and detecting memory leaks. In your service definition, you can include the supervisor. We do this by creating a new service block and including async container supervisor environment. Then we need to tell the other services that they should report to the supervisor, in other words, that they're supervised. Then we can instruct the supervisor to monitor those services. For example, here we impose a 400 megabyte limit on all the supervised services. If a memory leak is detected, then the supervisor can take various actions with the child process, including dumping its memory for later debugging and or terminating it. Memory limits are extremely important to the general application health, as without them the operating system will start killing processes at random, which can cause instability in your application. In addition to this, you can also create your own monitors and hooks into the supervisor to keep track of any specific details you care about. So the supervisor service provides a robust framework for monitoring the application, including memory usage to ensure application stability. Now let's talk about how to trace your application with the traces gem. So tracing execution of the application is a useful way to measure performance, including monitoring the latency of various operations during the execution of a request. Here is a small example showing a single request that took about 10 milliseconds, of which most of the time was spent rendering the response. On a more complex example, you might see database queries, cache lookups, or other services, giving you insight to performance issues in your application. Anyway, there are multiple providers of tracing, and the vast majority of them have libraries of monkey patches to add instrumentation to existing code. But I wasn't really happy with that approach. It felt very invasive and fragile, and I especially didn't want people monkey patching my code. so I decided to be proactive and created the traces gem. The interface allows you to optionally instrument existing code with minimal overhead. So here's an example showing how to provide traces to an existing class. Here's the method we want to trace. And so we define a trace provider for that class. And then we wrap the method in a trace using super to call the original implementation. And if you run this code with tracing enabled, then you will see a traces captured for that method call. When I originally built the traces gem, many of the providers were defined in line with the library code, but that made it impossible to disable them. So I'm taking a different approach now. For new providers, they are defined in a separate file, which you have to load explicitly. So this gives you control over what's going to be traced and what's not traced. If you want to get a list of these providers, you need to run the bake traces provider list command, and this gives you all available providers that you can use. So then you should add those to your config traces configuration file to add the providers that you're interested in. We also need to add the traces gem and a suitable backend to our project. And then to enable tracing, we specify a traces backend environment variable. So if you do all this, then you can get full tracing for all the requests like this. Also, async HTTP supports distributed tracing according to the W3 tracing specification. So if you use it for both the client and the server, you can get tracing between services. There is also an open telemetry backend for tracing, which I think going forward is going to be the default, but there's still missing functionality. So application tracing is an extremely powerful tool that can give you valuable insights into application performance, and it's fully supported by Falcon and the wider async ecosystem. Now let's talk about metrics. So metrics are things like counts, durations, or sizes, and they're measured in aggregate, meaning they can be efficiently stored in a compressed time series database. The metrics gem also has a similar interface to the traces gem. Here we have a method that we want to count the number of calls, and so we define a metric for call count of type counter, and then we wrap the method and increment the metric. It's very similar to the traces gem in that you need to opt into the metrics that are relevant to your application. you can get a list of available metrics providers using the bake metrics provider list command. And then you should create a config metrics file and add the providers that you're interested in. Like traces, we also need to add the metrics gem and a suitable backend. And then to enable metrics, we need to specify the metrics backend environment variable. After collecting some data, you can draw pretty graphs like this one, which displays finished HTTP requests grouped by status code. So I got asked recently, when should you use metrics and when should you use traces? And in addition to that, if you're experiencing issues, you might use a profiler. So basically, a profiler can capture every detail of your program's execution, while traces capture specific parts and metrics count specific events. They help you answer different kinds of questions like, how did it fail? Or what failed? Or did something go wrong? But there are different costs. A profiler generates more data and has bigger overheads, while metrics capture less data and has smaller overheads. So what kind of instrumentation you use will depend on what kind of question you're trying to answer and what kind of costs you're willing to accept. Application metrics are a useful way to track high-frequency events and detect error conditions, and they are well supported by Falcon. Finally, let's talk about logging. The console gem provides a simplified logging interface that supports multiple adapters and outputs. We use a subject-based log format where the first argument is the subject of the log, and we can also include structured data. Here are some more examples showing the different log levels and error handling. The console gem is flexible, and you can enrich or redact log messages by adding output wrappers. Here is an example that adds log correlation based on the Datadog trace context. Now when we emit logs, they will be attached to the specific request, which can be extremely useful for debugging. There are also several adapters to integrate existing frameworks with the console gem for logging. For example, the console adapter Rails gem. This provides structured logging for key operations in Rails. So, Falcon has great support for unified logging via the console gem. In summary, we have automatic health checks to detect hangs and stalls, a supervisor framework that can detect memory leaks and support custom monitors, flexible application tracing and distributed tracing, application metrics, and unified logging with flexible processing and trace correlations. So we've talked about building, deploying, and monitoring Ruby web applications with Falcon, but this talk had a lot of information. Did you remember it all? Right? Fortunately, there's a simple solution. Let me introduce the Falcon Rails gem. So where possible, it includes many of the things we talked about today by default, including, of course, Falcon, localhost, async job, async cable, traces, metrics, and console. But that still requires you to do actual work. So let me introduce the agent context gem. This gem copies documentation into your project suitable for AI agents. So now you can just ask Claude to do the work. Claude, consult agent.md and update my application to use Falcon. So there's really no excuse not to try this out. Together, let's take Ruby to the next level with async, Falcon, and Rails. We've proven it at Shopify scale. We have full support for Rails 8. You can build the next generation of interactive web applications to delight your users. The deployment is super simple, including comprehensive monitoring. So be the next success story, building, deploying, and monitoring Ruby web applications with Falcon. Thank you.
Thank you, Samuel. Yeah, any question?
Does it support only Rails 8 Plus or Rails 7?
Like Rails 7 is like the journey was Rails 7 was really the first point where anything worked at all, but there were still like missing pieces. Rails 7.1 fixed a lot of the main issues, but I still like people have made it work, but there's still quite a few like guns where like things can go wrong and you might not realize it. Rails 8 is the first version where we basically like fixed everything. Although the last one, so I've been working for like over 2 years to try and fix Action Cable. And I've been working with Falcon, and he was one of the authors of EV Cable. And so we have similar interests to try and make it easy to plug different servers into Rails. We made the whole pull request to like fix everything. And so here's a bit of politics for you. Matthew from GitHub, he was the one who was triaging this on the Rails side. And he was like, I'm going to merge it. And like this was like after a year of like working on this. And then he's like, I better go and check with like DHH. And then DHH was like, no, you cannot merge it. Like you have to test it in production first, and you can't test it on my system. And we're like, who else uses Action Cable? Like no one. So if you have Action Cable in production and you can try it out, it'll be awesome because you can help us. So what we did was we took that whole pull request, we put that into a gem called Action Cable Next, and basically the first thing that gem does, I think, is just load Rails and remove all of the Action Cable code, and then it loads like the complete, like the pull request to make the whole thing. And so like, honestly, it's kind of surprising it works as well as it does. So if you load async cable, it actually depends on Action Cable Next, and so basically replaces the whole of Action Cable in Rails. And so I really look forward to like the time when DHH is happy to merge that pull request, basically.
So the reason for my basic question was that we just released a new Debian version yesterday.
Yeah.
Now Rails 7 as default, so we're going to have like Rails 7 for 2 more years.
Yeah.
So if you want to run something on the Debian stable and serve with Falcon,
Yeah.
you will have to use Rails 7 because we are not going to get any backports. So
Yeah.
if it has Rails 7 support, then only we can run that on a daily Debian stable.
I mean, you can try it.
Because almost all servers basically run on Debian, so.
Yeah. All servers run on Debian. Okay. Yeah, I guess people have to make their own decisions on what that looks like. I would say that if people aren't bundling their dependencies in production, then they're basically doing it wrong anyway. Like if you're using system packages to deploy to production, it's pretty much a bad idea. So I don't think it's like basically like I don't think that's a problem. Basically, I think you should be like having a gem file, choose the right version, and then deploy. But yeah, it's not. I can't solve that problem. I can't go back in time and fix Rails 7.
You have to fix Debian.
Yeah, that's right. Don't fix Debian. That's my next project. Yeah.
Yeah, like the settings for Rails to use fibers,
Yeah.
the config, that's actually like Falcon or Falcon Rails does that automatically for you?
Yeah, Falcon does it automatically.
Yeah.
There's some situations where it doesn't work.
Mm.
Like basically, if you put the Falcon gem into your gem file, Rails will load it. And then we'll load the rail tie inside Falcon, which sets the configuration.
Mm.
So like 99% of the time that will work. But if you use active record by itself with async without Rails,
Yeah.
then you won't get that loading mechanism.
Yeah.
And then so you won't like that's why I pointed at configuration.
Yeah.
Actually, I proposed to Rails they should just use that by default.
Mm.
But then within 20 minutes my pull request was closed. They were like, no, we're not doing that. So that was the end of that.
Yeah, yeah.
I'll try again next year.
Yeah. So we have to set it if we are not using Rails but using like active record
If you just use
directly.
active record and async, then you
Yeah.
should definitely set
Yeah.
that setting. That's why I included like there's the configuration version, but then there's just like the direct version. Because the configuration basically Rails copies that config into all the different dependencies when it boots. So if you're just using like active record and async, then you need to use the second version, which is where you just go like active record base, like whatever.
Yeah.
Yeah.
Thank you.
Yeah, no problem.
Any question?
Hi. I want to ask about the. I saw there is a support for the HTTP 2, but is there support for the next? Like I don't remember the there's a protocol name, but it's a HTTP 3.
Yeah. So like it's I started working on support HTTP 3 maybe 2 years ago.
Oh.
And I had like a working prototype, but I'm still not convinced that we're in a good place to deploy it
Okay.
yet. The reason why is because right now, so there's the quick protocol, and there's a couple of really good C libraries for it, like libng, TCP2, and libhttp something, maybe? There's two C libraries that do it really well. And so one way to make it work is to make the foreign function interface into Ruby, and then use those C libraries to do like all the heavy lifting, like encryption, framing, network I/O. And we can plug that into the event loop, like that works, no problem. And I have a working proof of concept like client server. But what's happening very recently is that the Linux kernel is actually considering building quick support directly into the kernel. And so what that looks like is that the Linux kernel can actually manage all of the connection state and all of the initial connection setup. And then you just do your standard like, hey, I need to open a connection, send and receive some data, close the connection. And then all the multiplexing is handled in kernel space. I don't mind using the C libraries, but I kind of don't know like where we're going to end up yet. Like, is it going to be something the kernel decides to do, or is it something we should do in user space? Now we can just do the user space to start with and have something that works, but I really haven't had enough time to figure it out yet.
I have another question. So, I think my next question is more along the line how the async is it async job? Do you have a way to list any running? I don't know if it's the right question. Like, is there a console or like a terminal way to list the running processes or threads, or is it just?
There are standard mechanisms for doing that.
Okay.
There's a gem called async debug, which you can put that into any process that's running async. So even like async jobs runner, you can put this async debug, and then it creates a web page that you can connect to, and you can see like all the things that are happening in real time.
Okay. Okay.
So there are like some tooling, but it's like very primitive. It's not like as good as like let's say like not as mature as Sidecode.
Okay. Thank you very much.
Thank you.
So you mentioned about so Falcon can I usually use Docker and Docker Swarm and the plus traffic to do the deployment.
Yeah.
So if I use Falcon, can I just avoid the use of traffic? I can. This means I can use one Docker file and run Falcon and listen the correct server names.
Yeah, pretty much.
Oh,
It should definitely be easy. My goal has always been, one of the things I really hate is when someone's like, okay, to deploy this to production, here's like this, like 50 lines of things you have to do. And it kind of seems insane to me, like, okay, just put that into a shell script and then make it one thing. So I always, when I was creating the configuration file, I was always like, in my mind, I was like, how do you make it really easy to do the right thing?
does it support the big file download? You mean if you use that in Puma, that sometimes will fall.
Yeah, so, I guess what you're asking about is like, is there any point to use send file at the operating system level?
For example, we use Thruster currently to support big file download.
Basically, if you run Falcon on localhost, it can do multiple gigabytes per second.
Yeah.
So you can saturate pretty much any like network connection based on the hardware that you have. The challenge would be with HTTP 2, the framing is very different from HTTP 1. And so with HTTP 2, if you have a big file, you still have to like break it into pieces and send it out across the connection. And there's flow control and rate limiting that go into that. So to answer your question, I think that the need to serve big files at the front end is diminished when you use Falcon. And I think you should experiment just using Falcon and see what the performance is like. And make a decision.
Okay. So I can still use Falcon as what I used in Puma. Just listen port. Just
if you're using Falcon behind Thruster, you can do that.
yeah.
That's no
Okay.
problem. But like, I don't recommend it. But like, you can do it.
Okay. Thank you.
If you'd like to ask more questions, just come and chat afterwards.